Aeronautical communications engineers frequently have to calculate the range of their radio aid stations, for DME, etc. In this regard, the International Telecommunications Union provides a calculation model for aeronautical and satellite communications. The recommendation is P. 2345. It should be noted that the P. 2345 recommendation is a technical document that derives from a mathematical model developed by the Institute for Telecommunications Sciences. This mathematical model called IF77. This model is applicable to air-ground, air-air, ground-satellite, and air-satellite paths. It can also be used for ground-ground paths that are line-of-sight or smooth earth. This model are restricted to telecommunication systems, operating at radio frequencies from about 100 MHz to 20 GHz. The ICAO in the document, Handbook on Radio Frequency Spectrum Requirements for Civil Aviation, of the year 2019 indicates that the curves derived from the IF77 model are useful to determine the signal attenuation. It is possible to determine isocontours of reception power levels that are very useful for ground-to-air communications. The IF77 model is widely used by communications software development companies because it is a very powerful model and has proven to be the initial step to estimate the range coverage of a radio aid station. For some years I have been developing the Acrcom program. I use the IF77 model to estimate the coverage of the range of a radio station. The Acrcom program results in a coverage radius based on parameters such as transmission power, frequency, level minimum reception power of the aircraft communications equipment, geographic environment, aircraft flight height and various other technical data. The coverage radius allows us to draw a circle within which there will be a reception power level that allows consistent communication between ground station and aircraft. As can be seen, results can be viewed in Google Earth. Results can also be exported to KMZ format. For the example, we will use the coordinates of the Huánuco Airport, Peru, as seen in the images. The program identifies the level of reception power of the aircraft and according to this value, draws a contour that we can see in Google Earth. As can be seen, the Acrcom program has already finished calculating the ranges based on the technical parameters entered, and also identifies the value of the isocontour of the reception power level. Then we can see the coverage graph in Google Earth. We must indicate also, that the isocontour curves will vary according to the flight height that is entered. The topographic database used is the SRTM1. Any questions? My data are at the end of the video. Thanks for your attention.